Hello and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today's problem is a little bit the same like the previous one when we have two bodies, M1 here, M2 here, they connected with a rope. This body is pulled with F1, but what's new here is this body is pulled to the left with F2. And basically F1 and F2 are given. F1 is 3, F2 is 4, mass 1 is 1, mass 2 is 2, and they ask us about acceleration A. And of course nothing is moving this way, it's a flat surface. So, standard operational procedure. First body, force F1, we already draw it on the picture. Gravity, M1G. Reaction from the surface, N. And it will be N1, and all of these are vectors, vectors, vectors. And then this rope, and we know already, and I'm not repeating it here, that it's acting on this body with a force T. And nothing more? No more forces. Coming back to this body, the rope is acting on this left body with a force T, but in this direction. It's a property of a rope. Tension is always along the rope, and the rope is always pulling towards itself. F2 we have, M2G we draw, vectors we put, and we put N2. And that's all we have. So we have the first body with 4 forces, and we have the second body with 4 forces. And a very important thing that I already discussed last time, that acceleration of both body is the same. If this body accelerates A, then this A. If this A, then this would be A. It just doesn't really matter. Alright? Okay, so if this is done, we have to draw first body, and we have to write this, which is vector form of second law of motion for the first body only. And when we expand this sum, we say F1 vector plus M1G vector plus N1 vector, right? Plus T vector equal M1A, and I put A, right? And I put A, and this is vector. I can put here the second body right away. I want to finish physics first and not necessarily put the axis here. I put second body. Second body has F2 vector plus M2G vector plus N2 vector plus T vector equal M2A, and A is the same vector, and that's the nature of the rope being non-elastic, that they move together like a system. And I skip this for this body. Yeah, it's a minus on my part. I can put this here for the second body, but I skipped it. Okay, we understand it's a small drawback. But basically those two equations. Now I have y here, and let's put x this way, like because I want to. Previously we put x that way, but this time we put this way. And to be like, not to be outdone, for the y-axis let's put y down. Why not? It's my right. It's your right to put it in any direction. So, the first equation for x. The first equation for x is f1. f1 that way, x is this way, minus f1. Boom. m1g, I'm not writing them already, those are perpendicular, so they're not the t. So looking on this body, and this is this t, and this looks in the positive direction of this x. So F1 plus t, right? Equals, and let's say I still assume that A, let's assume that A is actually that way, right? A is unknown, and so if A is unknown, let's put it in the positive direction. It would be M1A. I don't really want to write on A because it's obvious it gives me nothing, but let's write it. So F1 is 0, projection on A of F1 is 0, so is projection of T, so only M1G, M1G is down, so it's positive, minus N1 equals 0. Now I go to the second body, projection FT, FT is positive, because it's looking that way, the same way like M2G0, N2G0, T, this T, minus T equals, and acceleration is the same acceleration, unknown, and if it's unknown this way, then it's unknown this way, and it's this. And Y for this body, F2 is 0, M2G is down, M2G down is down, N2 up, so it's negative, equals 0, 4 equations, unknown. T is unknown, A is unknown, N1 is unknown, T I already wrote, A I wrote, and then 2 is another unknown. 4 equations, 4 unknowns. We immediately can exclude this. We can say N1 equal MG, M1G, and then 2 equal M2G. And that's very good. And so we have 2 equations only. This and this, and let's write it again, minus F1 plus T equal M1A. And the second, F2 minus T equal M2A. And this is 2 equations, and those are 2 unknowns in those 2 equations, because N1 and N2 we already solved them. So these 4 equations have split nicely in 2 pairs. This is solved, this we need to solve. T and A is unknown. Pause, how you solve it, pause. Of course, the easiest way is to sum this up, and you will have minus F1 plus F2, because when you sum this, those will go, equal, and you sum up M1A plus M2A, and then you say F2 minus F1 equal A factor out, M1 plus M2, and you have A equal F2 minus F1 divided over M1 plus M2. Very nice. And we can find T later. You can find it yourself. It's not very important. T should be somewhere between F1 and F2. So T is actually in between those, but let's now finish with A first, and then we'll discuss T. So when we put the numbers, we will have F2 is 4 minus 3 divided over 3. It would be 1 over 3, 0.33 meter per second. And let's look, A is positive, and that's why F2 is 4 and F1 is 3. So it's pulling this way. So we didn't know which way it was pointing. We pointed X and we decided let's put A the same. So we didn't get negative like before. In previous problem we get positive, and that's very good. So that means 4 is more than 3. The whole system goes to the left. And so it's exactly like 4. It's exactly like, if you look on this, it's exactly like the mass. Total mass M1 plus M2 being pulled this way with F2 minus F1. Right? And the result is the same, like total mass multiplied now multiplied by A equals the total force and the total net force F2 minus F1. So we get this situation that makes total sense. That is exactly like we are applying the difference of those two forces and into the direction of the bigger, higher force, but masses are together because this net difference between F2 and F4 is applied, is accelerating the total mass of M1 plus M2. So it makes total sense. Let's do one more thing with this. Let's discuss what happens like in the previous problem. This problem is kind of a little bit, remember the previous problem? The previous problem when there was only one force, F1, and the rope, and M2, and M1. This problem has this force F2. And we solved the previous problem without the force F2. But right now let's think if this solution satisfied is the same for that solution, because this is a particular case. Because this case means F2 equals 0, right? And otherwise it's absolutely the same picture, this and that. But only F2 equals 0. So if we use this formula here, we receive A equal minus F1 divided M1 plus M2. And if you look in the previous problem, you will see that it's exactly like this, only A becomes negative. And this makes total sense. We say positive direction this way, but if we have only this force, everything is moving this way. Accordingly, the formula should give us negative, because A is directed this way, it's our assumption, and we receive that it's directed in opposite way, so it's minus. So it's very, very nice. And the only thing that left, and let's do it it's about T. For example, from here, T equal M1A plus F1. And if we put T, it would be M1 F2 minus F1 divided over M1 plus M2 plus F1. T equals common denominator M1 plus M2. Here M1 F2, I am opening brackets, minus M1 F1 plus M1 F1 multiplying here plus M2 F1. Those two gone, and we receiving this number, well, I don't know, let's write it here. Let's continue here. We're receiving this T equal M1 F2 plus M2 F1. We're receiving very symmetrical result, which makes sense because rope doesn't know who is left, who is right, who is bigger, who is smaller. And this tangent actually operates in such a way that it's a little bit bigger than this F1 in that particular example, if you plug the numbers. So it pushes this way, but it's a little bit smaller than this F2. And that's why everything is moving in unison to the left. We can plug the numbers here and we can say M1 is 1, F2 is 4, plus M2 is 2, and this is 3, and this would be M1 plus M2, it would be 1 plus 2, it would be 4 plus 6, and this would be 3, and would be 10 divided over 3, and it would be 3.3. And this is the thing that I am telling you, that this 3.3 is a little bit bigger than 4, is a little bit bigger than 3 because this is 3. So 0.3 is the total force that pushing this mass of 1. So 0.3 is the total force that moving this mass 1 of 1. And here it would be 4 pulling this way, 3.3 pulling that way. So it's like 0.6 a total force pulling this way, and mass is twice. So mass is twice, m2 is 2. So acceleration here would be 0.3, this divided over 1, and 0.6 over 2, it would be the same acceleration. So what I was, and you can prove if you want, I just don't want to spend time on this because it's not conceptual, but this is always the case. So this formula is such a case that it's somewhere between those two forces, F1 and F2, and it's like exactly the number that overcomes F1, but not enough to overcome F2, and so that's why masses are the same. It's all combined here in this magic mass formula, that those two bodies are moving with the same acceleration, and we found this acceleration. So this formula is very simple to understand, the net difference in forces. This formula requires a little bit more analysis, but I gave you the simple example with the simple numbers, and I hope it's satisfactory for now. I hope you liked. I hope you will subscribe. I hope you will have a question. If so, don't hesitate. Put it in the comment. See you next time. Thank you very much.